If you turn this video at one point off, then please tell me what the reason was so that I can improve. Otherwise, hi and welcome. I am trying to learn biochemistry. Today, carbonic acid, and after we've done with it, we're going to do squat training. And if you participate in the squat training, then it's better your own risk. Now we're having here this article about maintaining pH buffer system, and that is about the carbonic acid, which acts when importantly as being able to making a solution more acidic and more alkaline. At the same time, the same stuff can act in both directions, because it can be both a minus and a plus, basically. And we're going to read it now, and when we try to look exactly what is here told about the carbonic acid, then try to remember it and make a presentation about it. So, maintaining pH buffer system. Although the pH of body fluids may differ, the normal limits for the various fluids are generally quite narrow. Homeostatic mechanisms maintain the pH of blood between 7.35 and 7.34, slightly more basic than pure water. So it is important for the human body to stay very exactly with the balance of alkaline substances and acid substances. Saliva is slightly acidic and semen is slightly basic. Because the kidneys help remove excess acid from the body, urine can be quite acidic. Even though strong acids and bases are continually taken into and formed by the body, the pH of fluids inside and outside cells remains almost constant. Okay, they're saying the human body can take and is doing all the time acids and bases out, and is also eating acids and bases, but still there's one important reason left, and the one important reason is the presence of buffer systems, which function to convert strong acids or bases into weak acids or bases. Strong acids or bases ionize easily and contribute many H+, or if they are bases, OH- to a solution. Therefore, they can change pH drastically, which can disrupt the body's metabolism. Weak acids or bases do not ionize as much and contribute fewer H+ or OH-, hence they have less effect on the pH. I don't understand it well. The chemical compounds that can convert strong acids or bases into weak ones are called buffers. Okay, there are stronger acids and weaker acids, but I thought we could be completely turned around to the other side. Whatever. They can be formed into weaker or harder ones, and that is quite easily possible. Strong acids ionize easily and contribute more H+ to a solution. Therefore, they can change pH drastically, which can disrupt the body's metabolism. Weak acids do not ionize as much and contribute fewer H+. Hence, they have less effect on the pH. The chemical compounds that can convert strong acids or bases into weak ones are called buffers. One important buffer system in the body is the carbonic acid bicarbonate buffer system. Because carbonic acid H2CO3 can act as a weak acid, and the bicarbonate ion HCO3 can act as a weak base, this buffer system can compensate for either an excess or shortage of H+. Okay, carbonic acid. Maybe I should change the title a little bit. Carbonic acid can be a weak acid, and bicarbonate ion can be a weak base. So the one can be an acid, the other one a base, and it's the same stuff as far as I understand it, just different mixture. It's H2CO3 or HCO3-. So they're completely the same. It's not the same. There's the H missing. Maybe we should change the title a little bit, so it's maybe the carbonic acid bicarbonate buffer system. Where we're going to go with that. For example, if there is an excess of H+, and that makes it acidic. H+ is acid, OH- is base, or alkaline. Base and alkaline are the same. If there is an excess of H plus and acidic condition, HCO3 minus can function as a weak base and remove the excess H plus as follows. There's hydrogen ion, the H plus, or acid, or the thing which makes it acid, and our bicarbonate ions, or carbonic acid, but it works not the other way around as a bicarbonate ion. Whatever the name for the main stuff is. Maybe we don't have it, so we're going to go with the acid bicarbonate ionization buffer system, what it was. Acid bicarbonate buffer system. Carbonic acid bicarbonate buffer system. I know, it's carbonic acid bicarbonate buffer system. So it's the carbonic acid bicarbonate buffer system, because it can be carbonic acid or probably it then carbonic bicarbonate ion. The carbonic acid bicarbonate buffer system. The carbonic acid bicarbonate buffer system. Now the thing can be HCO3, and together an HCO3 minus together with an H plus, so too much acid, can give carbonic acid, which is H2CO3. And that is the same, or goes to be just water, H2O, and carbon dioxide, CO2. Are now carbon dioxide and water the weaker acids? Dioxide, maybe carbon dioxide is an acid. It is carbonic acid, and carbonic acid is nothing else than water and carbon dioxide. Then carbon dioxide must be an acid, or together with a solution. On the other hand, if there is a shortage of H plus and alkaline condition, so base or alkaline condition, H2CO3 can act as a weak acid and provide a needed H plus as follows. At an H2CO3 or HCO3 minus. H2CO3 or HCO3 minus. HCO3 minus. HCO3 minus. HCO3 minus. HCO3 minus. Or HCO3 minus. Or H2CO3. It's every time O3. It's the H missing. So the H is the acid thing, the H plus. So having H2 and CO3 or HCO3, the acid is gone. One H less. Not H2, just H. Then we're having minus. If there is a shortage of H plus, an alkaline condition, H2CO3 can function as a weak acid and provide needed H plus as follows. H2CO3, the carbonic acid, which we had gotten from hydrogen ions and bicarbonate ions also one time. So just carbonic acid, weak acid, can become a hydrogen ion and a bicarbonate ion, HCO3 minus, which is now the bicarbonate ion and can be used again to make too much H plus away. By taking again an H plus, making again carbonic acid, which is the same as water and carbon dioxide. Buffers and their roles in maintaining acid-base balance are described in more detail in chapter 27. Then we're going to call our video carbonic acid and carbonic bicarbonate. I think that is carbonic bicarbonate. That makes sense. We're saying carbonic acid and carbonic bicarbonate. We're having bicarbonate ion. Why is it bicarbonate ion and not carbonic acid? Carbonic ion. Carbonic bicarbonate. Bicarbonate ion is HCO3 minus, or HCO minus 3. Now that is actually a new problem. That means we can't really continue without knowing it. That means I think we're going to go actually to chapter 27. Bicarbonate. Bicarbonate ions HCO3 are the second most prevalent extracellular anions. Normal plasma HCO3 contraction is 22 to 27 MEq per liter in systemic arterial blood and 23 to 27 MEq per liter in systemic venous blood. HCO3 concentration increases as blood flows through systemic capillaries because carbon dioxide being released by metabolically active cells combines with water to form carbonic acid, which dissociates into H plus and HCO3-. As blood flows through pulmonary capillaries, however, the concentration of HCO3- decreases again as carbon dioxide is exhaled. Intracellular fluid also contains a small amount of HCO3-. As previously noted, the exchange of Cl- for HCO3- helps maintain the correct balance of anions in extracellular fluid and intracellular fluid. The kidneys are the main regulators of blood HCO3 concentration. The intercalated cells of the renal tubule can either form HCO3- and release it into the blood when the blood level is low, or excrete excess HCO3- in the urine when the level in blood is too high. Changes in the blood level of HCO3- are considered later in this chapter in the section on acid-base balance. Acid-base balance. From our discussion thus far, it is clear that various ions play different roles in helping to maintain homeostasis. You understand it? So I don't know where we're going to continue. Not with presentation without knowing how the second thing works. Maybe we're going to go in the next video directly to the thing, here now on chapter 27. Maybe not, and we're going to do something else in biochemistry. That means that was the biochemistry part. We will continue with biochemistry in the next biochemistry part, maybe with the acid-base buffer system. If you go for that here, you can go directly to the next video. If you stay here and participate in the Squattraining, then it's better to honest. Wir bringen one leg up and pointing with the toaster. Our leg up and point with the toaster. Take the leg at the ankle, make a straight leg, and point with the knee down to the ground. Upper leg, straight leg, and knee down to the ground. And to the side. The toes are pointing in front and we're stretching the inner side of the leg. And over to the other side. Now go from side to side. And up again. And now we're doing 12 squats. Legs wide apart, and we're going down to the first one and the second one. Number 3, 4, and number 5, and 6. We're having a half, so number 7, and 8, 9, 10, and just 2 more, number 11, and the last one, 12. And now the 6-pack squat squeeze. Down into quarter squat and press against the top part of the leg. Just on one side. And on the other side. Down into half squat and press against the middle part of the leg. And on the other side. Down into 3/4 squat and press close to the knee. And on the other side. Next exercise, the fastest giraffe of a water pond. Down into 3/4 squat, press against the knee, go towards it. On the other side, press, go towards it, and again, press, go towards it again. And 2 more, press. That's the last one. And up. Last exercise, the propeller. Down into full squat, arms to the side, over to one side, press against the leg, and look up to the knee. In the middle, over to the other side, press against the leg and look up to the leg. And up. Walk a bit on the place for walker. Heel onto the ground, pull the heel in, move the leg from left to right. Our heel onto the ground, pull the heel in, move the leg from left to right. Take the leg as the anchor. Straight back, knee down. Our leg, straight back, knee down. Next for the part, breathe finger down. Out. One more round, breathe in. Out. Breathe in across the legs. And breathing out. That was my squat training. I thank you very much, man.